This video is meant for the doubt you have raised for the assignment which I gave you. So here, what you have raised is you haven't quite understood clearly regarding Instantaneous Centre Method. So I'll discuss one of the problem which I gave you for the assignment, and you can make use of that particular technique to solve the other problems as well. So Instantaneous Centre Method, as far as the method is concerned, it is quite easy, and you can make use of the graphical approach in order to solve problems. You can also make use of analytical approach by the same method to solve problems. So here in this discussion, I'll be concentrating on the graphical approach, making use of the Instantaneous Centre Method. Okay. Now this question, here you're given a 4-bar mechanism, and in which the crank 2 angular velocity is be given, that is 60 radians per second clockwise, and you're asked to find out what is the angular velocity of link 3 and link 4, and also the velocity of the pin at point B and point C. So here what you have to understand from this particular diagram is that point C and point B can be considered as lying on link 3 itself. Okay. Why? Because point B is a common point for link 3 and 4, so it's also lying on link 3. Whereas point C is an extension of link 3. You can see DC is the other extension. Actually, at point B, it is firmly welded together, so it is integral part of link link 3. So point C is also part of link 3. So I'll be concentrating on link 3 to find out the velocities for point B and C. And also you can find out what is the angular velocity of link 3 from that particular solution itself. Now what you have to do initially is that once you get a similar problem like this to solve by Instantaneous Centre Method, the first and the foremost thing is to draw this diagram to a particular scale. So the various dimensions for the links are given beneath that figure. Making use of that particular dimensions and the orientation, if it is given as 210 degree for link 2. So based on that orientation and the dimensions, you can draw this particular diagram to a particular scale. So that's the first thing you have to do. Now, after doing that, we have to go for a series of procedures in order to solve it. Now, let's see how we can do it. Now, the first and the next step to be done is, after drawing the diagram to a scale, you have to identify the 3 links which you have to consider for the finding out the solution. Now, the 3 links which you have to consider is always you have to consider link 1, because that is the fixed link. For any combination of 3 links, one of the link will be the fixed link itself, and the second link will be the input link. Input link means where the value for velocity or omega is known. So that is considered as a input link. So that also has to be a common factor for all combinations. Now the third link is the link where the point is lying, whose velocity is to be identified. So in this particular case, we got point B and point C on link 3. So that's why we are considering link 3 as a third link. Okay. Now, using these 3 links, you have to identify the various combinations of instantaneous centers, and all these instantaneous center has to lie in a straight line. So that's what is being said by the Arnold-Kennedy theorem. So we have to see that. So let's go to the figure first. So in that particular figure, you can see we have chosen 1, 2, and 3 as links, and the various combination of instantaneous centers are 1, 2. And 1, 3, and the other combination is 2, 3. Okay. So these are the 3 combinations of instantaneous centers we can get. Now coming to that figure, you can see those things where 1, 2 is lying. 1, 2 is actually the common point between link 1 and link 2, that is positioned at O2 itself. And the other instantaneous center, that is 2 3, which is known to us, that is quite easy for you to identify. That is a common point between link 2 and link 3, and that is the point A, which you can see as a joint. So these 2 points, so let's see. So 1 2 is being numbered as a red colored letters, and 2 3 is also numbered similarly. So what you can do, you can find out 1 3 by just connecting a line between 2 3 and 1 2. So that that defines the locus of 1 3. So that means you are getting one of the locus for 1 3. So that's what I am drawing it. Okay. Now we have to identify the second locus. In order to identify the second locus, you have to consider the combination of the other 3 links. So the other 3 links is 1 3 and 4. Now corresponding to these 3 combination of links, I can have 1 3 1 4 under the link 1, which is the corresponding combination between 3 and 4. Now the other combination between 3 and 4 is 3 4. Okay, so these are the 3 combination of instantaneous centers we have. Now you just identify those instantaneous centers where it is lying. So we have 1 4 1 4 lying at point O4 itself, and we have 3 4 at point B. Okay, so these are the 2 instantaneous centers we already know. Now connecting these 2 points together, we will be having the second locus, and that is being drawn now. Okay, so that means we have 2 locus now, both are intersecting at a certain point, and that point will definitely be 1 3. So that is being shown there. Okay. Now actually the line connecting 1 3 1 2 and 2 3 form the line of centers now. Why we are considering this as a line of centers is only because we have to find out what is the velocity of point C and what is the velocity of point B, and both are lying on link 3. So that is a first consideration we are taking now. Now based on that only, we have chosen the line of centers as 1 3 1 2 and 2 3. Okay, now what you have to do, actually the point 2 3 which is lying on the line of centers is actually part of link 2 as well as link 3. Okay, now if this is lying on link 2, if point 2 3 is lying on link 2, then definitely we can find out what is the velocity of that point, because you already know what is the angular velocity of link 2, and you can identify what is the distance of 2 3 from the center of rotation, that is 1 2. Okay, so definitely we can find out what is the velocity of point 2 3. Okay, since it is lying on link 2, and also we can see why we are considering it like that, only because omega 2 is given to us. So we can find out what is the velocity of any point lying on link 2. Okay, we know, because we know what is the center of rotation of link 2, we know what is the angular velocity. So only thing is that we need to identify what is the distance of rotation of that particular point, or the radius of rotation of that particular concerned point, and multiply that distance with the angular velocity. You'll be getting what is the velocity of that point. And always you can see that the velocity of point 2 3 will be equal to the distance 2 3 1 2 2 3 1 2, that is the distance, into the angular velocity omega 2. So that you, after finding out that velocity, you choose a particular scale and draw it perpendicular to the line of centers from the point 2 3. Okay, so from the point 2 3, you are drawing the velocity vector corresponding to its magnitude, and it is perpendicular to the line of centers now, right? Now the second consideration is that we know that this is the point 2 3 is a common point between 2 and 3. So definitely now you can consider it as lying on the third link. This point 2 3 is lying on the third link. So that means the velocity of that point is actually known to us, and that is v23. Okay, now what you can do is you just connect a line from the fixed point of link 1, link 3. The fixed point of link 3 is actually 1 3 itself. Why? Because 1 is actually numbered as the fixed link. So whenever you have a combination of instantaneous center with link 1, definitely that particular point will be a fixed point. That will be a fixed point. So measuring the velocity with respect to that fixed point will give you the absolute velocity of the respective point. So here what I'm trying to do is I'm trying to connect a line from 1, 3 to the tip of the velocity vector 2, 3 in order to identify what is the locus of the tip of the velocity vectors of all points lying on link 3. Now I got the locus of the tip of velocity vectors of all points lying on link 3. Whether if I take a point D, if I take the point D, it is, since it is lying on link 3, what I can do is I can transfer point D onto the line of centers. From there I draw the vector perpendicular to the line of centers, so that I can see that the tip of the vector will be touching this locus, so that I can measure the magnitude now. Okay, now let's see how we can find out for links the point C. To find the velocity of point C, since it is lying on link 3, I can transfer the point C onto the line of centers. So that is being done radially. I have to once you transfer it radially, you have to transfer it based on the fixed point. So the fixed point of the third link is 1, 3. So with respect to 1, 3, you transfer point C onto the line of centers, right? From there, you draw the vector perpendicular to the line of centers, so that the tip of that vector will be touching the locus, and that will give you the measurement for the velocity of point C. Okay, so you measure that velocity, measure the length of that vector multiplied with the scale of the scale which you have chosen for drawing this V23 vector, and you'll be getting what is the absolute velocity for the point C. Okay. Similarly, you can find out what is the velocity for point B. What you have to do, just transfer that point B onto the line of centers radially with respect to 1, 3. Okay, then from that particular point, you draw the vector perpendicular to the line of centers, so that you'll be getting what is VB. Okay, so this is how you do it. Now, in this particular case, what you can see is, if you want to find out the velocity of any point which is lying on link 3, what you have to do is just transfer that point onto the line of centers corresponding to that link. So that corresponding to that link means that particular link should have a center of rotation with the fixed link. So that means in the case of the third link, it is 1, 3 itself. So what you can see is you have to consider the line of centers passing through the fixed point of that particular link, and then transfer that point onto the line of centers, and then from there you draw the vector corresponding to it, which is perpendicular to the line of centers, so that it will be touching the tip of the locus of the velocity vectors, so that the magnitude will be obtained in such a manner, right? Now, if you want to find out what is the angular velocity of link 3, you can see point C is also lying on link 3, point B is also lying on link 3, point 2, 3 is also lying on link 3. So if you can consider any of these velocities, and divide that velocity by the distance of that point from the fixed point of that link. Okay. So here what I'm going to do is, if I take VB, you take that magnitude of the vector and then divide that magnitude by the distance 3, 4, 1, 3. That is the distance from point B to 1, 3 has to be chosen, and divide the velocity by that particular distance. You'll be getting what is omega 3. And you can also get omega 3 by means of taking V23 as a velocity vector. Now divide V23 by the distance 2, 3, 1, 3. That is the distance of the point from the center of rotation 1, 3. Okay, so that is the radius of rotation of that is 2, 3, 1, 3 is the radius of rotation of point 2, 3. So you measure that distance and measure the magnitude of the velocity vector, and divide the velocity vector by that radial distance. You'll be getting what is omega 3. In all the three cases you do it, omega 3 will be the same. Okay. Now, if I want to find out what is the angular velocity of link 4, then what you have to do is you have to choose the velocity of point B. So point B is actually 0.34 itself, instantaneous center 34 itself. That means point B is also lying on link 4. So that's what you can infer from this particular instantaneous center 3, 4. So B is also lying on link 4. So what you can do is you divide this velocity VB by the distance 3414. If you divide the velocity VB by the distance 3414, because 14 is the center of rotation of link 4. We are trying to identify what is the angular velocity of link 4. So you have to consider the center of rotation for link 4, that is 14 itself. So you take VB, divide the distance, divide that velocity by the distance 3414, you'll be getting what is omega 4. The simple expression you are using, which is V is equal to R omega. So from that you can find out what is omega. It is V by R. So that is the same, that same principle is being used here in order to identify the angular velocities as well as velocities. Okay. So this is what you have to understand from this solution. So make use of this particular technique to solve the other problems in, for the assignment by Instantaneous Centre Method. So thank you for listening. If you have any doubts, if you have any further doubts, you just WhatsApp me or you can call me in my mobile. Okay, thank you.